So as I said earlier, sometimes we might want to have a logarithm presented in one way or another, where we got so many different ways we can do it as we've seen so far, because multiplying in a factor of 1 is a little weird for logarithms. Adding in a factor of 0 is also a little bit weird. It goes in some funky places, goes in some weird directions. But if we want to work in terms of making something longer or making it shorter, our main pieces that we have here are the product, quotient, and power rules, as we're going to see here with some examples going in both directions. So first, we're going to use the properties of logarithms to expand the following expressions as much as possible, where we have log base b of x cubed times y to the 1/4, and log base 7 of y to the 1/2 over 49y to the 4th. And don't be thrown here by the fact that that's log base b, that's very general. It's fine. It does happen that way, though. We'll want to talk about these things in terms of some very generally flavored behaviors, that we'll have a lot of variables we can throw around here for the sake of being weird and symbolic, because math is weird and symbolic, even though I am a little bit loath to admit that as a math teacher. I'm not supposed to tell you that, but whatever. For that first example, again, the fact that that's log base b doesn't actually change all that much. It's just that we don't have some specific exponents that we can think of things in. Though, again, that doesn't really matter at this point, because with our rules, we don't need to worry too much about that. And besides, we're looking at powers of x's and y's. Unless I made it log base x of x, which is a weird thing to think about, it wouldn't really matter. So we'll just use our rules here to pull this apart. We're going to start with the product rule, which says that because these things are multiplied, I can make them added. So we can do log base b of x cubed plus log base b of y to the 1/4. And then I'm going to use the power rule twice here. I'm going to pull down that 3. We will get a throg b, 3 times the logarithm of b, of x, plus 1/4 times the logarithm of b of y. And that's it. Maybe we'd have more information about x and y. We might want to change these around in some other way, but that's what we'd have. And for that matter, if you want to introduce more powers to x's and y, you can now do that, right? You just have to know how you're going to cancel things out on the front. Got lots of options, but that's what we want for number 1, because we're trying to make it as long as possible. And then for number 2, we could play basically the same game, except there we're starting from the logarithm base 7 of, is that a 1/2? That's a 1/2. X to the 1/2. It's a very small print. Over 49y to the 4th, where here, again, we're going to start with the quotient rule, because we've got division, and we will get log base 7 of x to the 1/2 minus log base 7 of 49y to the 4th. And this guy, just use the power rule. I'm going to slide him over just a little bit. We get log 7, there should be a 1/2 on the front there. It's very small, don't worry about it, but that's the 1/2, pulled it in the front, of x. And then for that second term, a little bit more can happen there. So we're going to say minus, and start a parenthesis. I'm going to split this up here, and we'll have log base 7 of 49. This is more traditionally how things are written, without that parenthesis in there as well, once you know that you're looking at that specific thing. Sometimes you'll see it, sometimes you won't. As I said, we're getting more comfortable here. I'm not always going to write it, and then I guess to be more consistent, I'll remove these guys too. Anyway, 49 and log base 7 of y to the 4th power, where, again, we have to be careful dealing with what happens in terms of that negative sign. But in here, we have that 1/2 log base 7 of x, then minus log base 7 of 49, which hopefully we recognize is 7 squared. 7 of 7 squared would give us a -2 for that term. And then over here, we'll just use the power rule because we don't have anything necessarily between 7 and y yet. So factoring in the negative, be very careful there, we would get minus 4 log base 7 of y. And that's the best we could do there. At the very least, that's the most we can do with this setup. We could maybe pull things apart even further if we really wanted to get creative with how we add in our zeros and multiply in our ones, but this is fine for what we'd be looking for there. These are, again, a little bit subtle for how many options you have. And because we saw one direction here, pulling apart, we'll see about going the other direction. That is condensing back down to the most simple, not really simple, but small, single term possible.